Okay, so today we do quadratic formula. How many have had a quadratic formula already? You're experts on the quadratic formula. Okay, so quadratic formula becomes another strategy for us to solve a quadratic equation. In fact, it's pretty much the only one that always works. Okay, not every quadratic equation is factorable, so you can't always say solve by factoring. Not every quadratic function crosses the x-axis, so you can't always say, solve by graphing, look for the x-intercepts. But every quadratic equation can be solved with a quadratic formula. And not only that, but you get the quadratic formula on the SOL and on any test I would give you. I would give you the formula. So you don't have to actually memorize the formula, you just have to know how do we plug numbers in to get it. Now, if you look at the bullets that are here, these are the SOLs. The requirements are, the first one says we're supposed to recognize that actually the quadratic formula can be derived by completing the square. Now, completing the square is the section just before 4.8, and we are going to do a little bit of that just to show where this comes from. Okay, and then it says solve a quadratic equation. Obviously, we're doing that. And then it talks about this thing called the discriminant. And those are our three goals, and we'll do all of those today. Good sheet. So this is from two classes ago, where we were solving by taking square roots. I mean, for the most part, we solved problems that didn't have, it only had a squared term. It didn't have the variable x to the first power. Then you could isolate the x squared, take the square root of both sides. Sorry. But we also had problems like this, which it's not really true that there's no z term here. I mean, if I foiled z plus 3 times z plus 3, it would be z squared plus 6x plus 9. Yes, you could do it that way. But because it was a perfect square trinomial, we still could isolate the variable in one place and solve for it. Right? We would have multiplied both sides by 35, taken the square root of both sides. So you say, okay, well, that's great if you have a perfect square trinomial. But what if you don't have a perfect square trinomial? Well, it turns out this process, completing the square, will allow us to make every quadratic equation into a perfect square trinomial. So you could actually use this method to solve any quadratic equation. Right? Now, completing the square to do this, I mean, it's not necessarily required that we learn this to solve an equation. You probably won't use it to solve an equation. But when you get to math analysis, they expect that you've learned this. How do you complete the square? I mean, at the very least, you got to be somewhat familiar with it. Because you learn it, you use it at the beginning of the class when you're going over quadratic functions, kind of like we are right now. And then at the end of the class, when you're doing the conic sections, which are ellipses and hyperbolas and parabolas and circles, every one of those, there's at least one and usually two times that you have to complete the square to put it in standard form. So, I mean, it has to be a process that we're a little bit familiar with. So it's actually not hard to complete the square. It's two simple steps. So let's say I've got x squared plus 6x. And I want to find a number that I can add to x squared plus 6x that would make that into a perfect square trinomial. Right? So you could think of it like a is 1, b is 6, and c is the number we're looking to fill in. So what you do is divide the b by 2 and square it. Right? So let's see. 6 divided by 2 equals 3. 3 squared equals 9. So put a 9 in the place of c. Okay, now, how does that factor? X squared plus 6x plus 9. What are the factors of 9 that add up to 6? 3 and 3, right? So this is a perfect square trinomial. X plus 3 squared. Now notice that when you take half of b, that 3, which is a plus, that's the number that goes there. But in this case, x squared plus 6x plus 9, we could have factored that anyways. It's a fairly easy factor. But it's not always the case. Okay, not always the case. So keep that in mind. How do you find the constant term? You divide b by 2 and you square it. 2 steps, not that hard. So try to do it for that one. Find the number that goes in place of c so that that is a perfect square trinomial. What did you do first? You took negative 24 and you did what with it? Divide by 2 and you got negative 12, okay? And then what did you do? Then you said negative 12 squared is positive 144. Don't make a mistake like that. That's a silly mistake. You know a negative times a negative is a positive. But if you put in your calculator negative 12 squared, it's going to tell you negative 144 because it didn't square the negative. You've got to be smarter than the calculator, or else you'd be better off without calculators. Okay. So if I put this as x squared minus 24x plus 144, then how does that factor? X minus 12 squared. Again, it's whatever that number, the half of b, that's what goes there. In this case, it would have been easy enough to factor, right? What are the factors of 144 that add up to negative 24? Negative 12, negative 12.
Do you really have to continue through, or can you just take the negative 12 and put it in immediately?
No, we need to keep track. I'll show you in a minute why. Because it's a good point. So if you don't really care about the 144, then why bother? I'll show you. It might be the next slide. Let's see. Okay, so now we can use this process of completing the square. We complete the square so that we could solve by taking square roots like we did 2 lessons ago. Okay, so this is how it works. Right, I already have like my 2 terms, the squared term and the linear term, x to the first, on the left, which is the way you want it. If it wasn't like that, you'd have to move a term to the right. But I'm going to write it like this, x squared plus 4x, and then I'm going to leave a space for that constant. And I'll complete the square on the 2 terms on the left using the process that we just did. Right? What do I need to add to x squared plus 4x so that it makes a perfect square trinomial? 4. Half of 4 is 2, right? 2 squared is 4. So that's the math. 4 over 2 equals 2. 2 squared equals 4. All right, so I add 4. But now, because we're solving an equation, I can't just add 4 to one side of the equation unless I balance it out somewhere else. So let's add 4 to the right-hand side too. If you add 4 to one side, you've got to add it to the other. That's why that last number makes a difference. Okay? Plus 4. Okay, now on the left side, we can factor it. That's a perfect square trinomial. That's x plus 2 squared. On the right side, we have 14. So now we created that situation where we have a perfect square on one side that we can take the square root in order to solve for x. So we do it. Take the square root of both sides. So we have x plus 2 equals plus or minus the square root of 14. Now can we simplify the square root of 14? Right, it's not a perfect square, it doesn't have any factors that are perfect squares, so no, we can't. But we're not done solving for x. Last step, subtract 2, right? So this will be x equals negative 2 plus or minus the square root of 14. Done. Okay, what kind of numbers are those? They're real. What subset of real numbers is it when you've got a square root like that? It's irrational, right? What that tells you, there will be times if you look at what we started with. What if I subtract the 10 to the other side? X squared plus 4x minus 10 equals 0. So you can ask yourself, is that factorable? Are there factors of negative 10 that add up to 4? And the answer is no, right? That's why you're getting answers that are irrational, because it wasn't factorable in the first place. Sometimes you're going to be looking at this, and maybe it is factorable, but you just can't think of it. Well, if you did that, then you wouldn't get a square root in there. It would come out to just rational numbers, not irrational numbers, but rational numbers. But because of that being an unsimplifiable square root, like the square root of 14, that's one that wasn't factorable anyways. Okay, I was supposed to fix something here. What was I supposed to fix? Okay, so try to do the same thing on that. Right? Make a space to the right of the 8x, complete the square, etc., etc. I want to go through here and make sure I got this right. Okay, so x squared plus 8x. Leave a space, negative 1. Okay, what do I have to add into the left-hand side? You have to add 16, right? Half of 8 is 4. 4 squared is 16. Okay, but if I add 16 to that side, I've got to add 16 to that side. Yes? Oh, sorry. Thank you. And this is x plus 4. Remember, that was half of the 8 equals 15. So we take the square root of both sides. We get x plus 4 equals plus or minus the square root of 15. Subtract 4. There you go. Now, the two that we just saw, a equals 1, okay? And when you complete the square, a has to be 1. That thinking of half the middle term and square it, that only works if a equals 1, okay? If a doesn't equal 1, then it looks like this. Something like that. So if a doesn't equal 1, you have to factor a from both terms, from the 2x squared and from the 16x. Okay, what is a in this problem? Is 2. So factor the a. And now complete the square on what's inside the parentheses, which we kind of just did this one. So what do I add into that position? 16. Okay, now what do I add to the other side to balance that I just put a 16 there? Yeah, you're going to have to do 32 because there's a 2 times outside parentheses. So you have to take into account that it's being multiplied by 2. So add 32. So now we're going to get 2 times x plus 4 squared equals 19. So we almost have a perfect square trinomial equals a number. I got to isolate the parentheses squared. What do I have to do? Divide by 2. Right? So divide by 2, divide by 2. So now I've got x plus 4 squared equals 19 halves. Okay? Take the square root of both sides. Okay, can I leave it like that? No, because I have a square root in the denominator. How do I get rid of the square root in the denominator? Square root of 2 over the square root of 2, right? So do that. And now we have plus or minus the square root of 38, 2 times 19, divided by 2. And then you still haven't finished solving until you subtract 4 from both sides. So x equals negative 4 plus or minus the square root of 38 divided by 2. Okay, and remember, I can't divide the 2 into 38 because the 2 is not inside the radical. So that's completing the square. That's what the process is. Now, we're not required to complete the square to solve problems, but we're supposed to know that actually the quadratic formula is derived by completing the square on ax squared plus bx plus c equals 0. That if we just don't have numbers in there, we just have the letters a, b, and c, that we will be able to complete the square. Or, sorry, to come up with a quadratic formula. So what I'm going to show you, what I'm thinking now is that what I'm going to do right here will be the extra credit on the next test, which is if you can repeat this process of deriving the quadratic formula, that'll be the plus 5. And I'm doing it right in front of you right here. I mean, you could practice it and have it ready to go. Okay, so you start with that right there. Okay. First step, remember we always started with a constant term on the other side, so let's move the c to the right-hand side. Let me do this, because it really fills up the screen when I do this. Let me make it like this. ax squared plus bx equals negative c. Right? If the c was positive on the left, it's negative on the right. Okay, now, like we did in that last problem, we have an a to deal with. It's not 1, it's a. So what did we do? We factor it from both terms. So that looks like this. Take an a out in front of parentheses, and you have x squared inside. What does the next term look like if you factor out an a?
Bx over a?
Yeah, bx over a. Good job. So that, or you could say it like this. b over a times x. Okay, equals negative c. Okay, now we have the inside parentheses, we definitely have the 1x squared. So we can complete the square using that two-step process, right? What's the first step? Divide the middle term, the coefficient of the middle term by 2. Okay, what will that be? Right. b over a divided by 2 equals b over 2a. And then what? And then you square it, right? So b over 2a squared equals b squared over 4a squared. Okay, so that's what we have to add inside the parentheses. So it'll look like this. A times x squared plus b over a x plus b squared over 4a squared equals negative c plus, okay, now what am I going to add to the other side? b squared over 4a, right? Not a squared, because that a is outside parentheses. That's going to cancel one of the a's. So this will be b squared over 4a. Okay, now what does that give us inside the parentheses? What is our perfect square trinomial here? It's x plus, remember, it's whatever you get when you divide by 2. So it's the b over 2a, right? b over 2a equals, and now I'm going to switch positions on these two. Let's make this b squared over 4a minus c. In fact, let's get a common denominator between b squared over 4a and c. What would the common denominator be? What's the common denominator between 4a and 1? 4a. So we need to multiply the last one, the c, by 4a divided by 4a. So that makes the right-hand side b squared minus 4ac divided by 4a. Okay, so now are we ready to take the square root of both sides? We have a parentheses x plus b over 2a squared equals b squared minus 4ac all over 4a. What do we have to get rid of first? That a right there, which is multiplying, you got to divide it out. Divide both sides by a. Right, that'll give us x plus b over 2a squared equals b squared, we're all the way over here, b squared minus 4ac divided by 4a squared. Now we take the square root of both sides. Okay, take the square root here, take the square root here. Okay, that'll give us x plus b over 2a equals plus or minus the square root of b squared minus 4ac. And then notice that the denominator, 4a squared, you could take the square root. What's the square root of 4a squared? 2a. So now that takes that out of the radical. It's 2a. Okay, and now we're almost done. Now we still have to solve for x on the left. Subtract b over 2a. Yeah. Yes. We're deriving the quadratic formula. Okay. So subtract the b over 2a and we'll get x equals plus or minus, oh sorry, that's wrong. That was wrong. Too early for the plus or minus. It'll be negative b over 2a plus or minus the square root of b squared minus 4a. Going crazy. B squared minus 4ac divided by 2a. And honestly, you know, because they're both divided by 2a, when you look at the quadratic formula, actually combines all this. It's negative b plus or minus the square root of b squared minus 4ac all over, right? This fraction bar is underneath all of that, 2a. That's the quadratic formula. Yeah. Sure. I mean, I post this on the website. It's, you know. So there you go. There's the quadratic formula. So it's useful because it'll solve any quadratic equation and you get it on test. So you don't have to memorize it. We used to have to memorize it, but I guess you guys can't memorize it, so we don't. So all you need to look at, the starting point is Standard form quadratic equation set equals 0. Right? As long as you got that, then you know what your A, B, and C are. You plug them in and you go. So here's an example. This is cut out of the book. Right? So notice that it didn't have a 0 on one side, so the first step was subtract 2 from both sides. Okay, then, based on that, it looks like the A is 1, the B is 3, and the C is -2. So notice how they've just plugged into each one of those positions for A, B, and C. Now, a lot of the mistakes that we make when we solve with the quadratic formula is that you don't simplify correctly. Like, for example, if you have a -b, when you plug it into b squared, you've got to be careful that b squared is positive. And some will continue to keep saying that it's negative because you're putting it in the calculator without parentheses. So you've got to be careful about that. And then some of this simplifying of square roots that we've learned in the last 2 lessons ago, right, comes in handy here. Okay. So why don't you try to solve that one with the quadratic formula. And it doesn't matter. If you want to put the x squared on the other side, obviously it'll be a -x squared. Or if you want to put the other 2 on the left, it'll all be opposite, right? The answer will come out the same no matter which way you go. So, the one thing, where we get weak, and this is really kind of like basic math kind of stuff, but because 2 is dividing both terms in the numerator, you can cancel the 2 goes into 6 to give you a 3, and the 2 cancels with the 2 in front of the square root of 5. I mean, if you like, you could write it like 2 terms first. You could make it 6 over 2 plus or minus 2 times the square root of 2 over 2, or sorry, 5, square root of 5. And then the 2's cancel, and 2 goes into 6 3 times. 3 plus or minus the square root of 5. Right? When there's one term in the denominator, if it divides into every term in the numerator, you can do that. Okay, so here's another one. So what do I have to do to this one? Get the terms on the other side, right? So I'm going to subtract 12x and add 9 to both sides. So that's 25x squared minus 30x plus 9 equals 0. Right, so A is 25, B is -30, C is 9. Agreed? So let's plug in the quadratic formula. X equals negative 30 plus or minus the square root of -30 squared minus 4 times 25 times 9 divided by 2 times 25. So if you have to do a solve with a quadratic formula problem, you should show the step where you here's where I plugged everything in correctly. So I can track it that far. Now I simplify. X equals 30 plus or minus the square root of, what's -30 squared? 900. What's 4 times 25 times 9? 900. Oh, well, that looks special. Divided by 50. So this is x equals 30 plus or minus the square root of 0 over 50. So what's the square root of 0? It's just 0, right? So x equals 30 plus or minus 0 over 50. Well, what's the difference if you add or subtract 0? Nothing. You get the same answer, which is 30 over 50, which is 3/5. So what kind of quadratic equation did we solve that only had one answer? Perfect square trinomial? So in fact, if you go back up to this 25x squared minus 30x plus 9, that was a perfect square trinomial. It could have been factored, you know, but that's what it looks like in the quadratic formula. When you get an answer from the quadratic formula, which is just a fraction or a rational number, that means it could have been factored. Maybe you didn't see it, but it could have been factored. You know, in the quadratic, if we would have solved that with the quadratic formula, it would have looked like this: 5x minus 3 squared equals 0. And so what are the answers? 3 divided by 5, 3/5. That's how it works. Okay, so you can get the first problem, we had 2 solutions, real. That one we had 1 solution, real. Okay, now let's try this one. Negative x squared plus 4x minus 5 equals 0. Okay, so a is negative 1, b is 4, c is negative 5. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 5 all over 2 times negative 1. X equals negative 4 plus or minus the square root of 16 minus what? Minus 20, right? The negative 1 times negative 5 is positive 5 times 4 is 20 over negative 2. So x equals negative 4 plus or minus the square root of negative 4 divided by negative 2. Okay, now what kind of answers are we going to get now? Imaginary, because we're taking the square root of a negative number. They're going to be imaginary. Right? What is the square root of negative 4? Negative 4 plus or minus 2i. Right, divided by 2. And then again, negative 2. So that is, divide the negative 2 into negative 4, that'll give you positive 2, and that's plus or minus I. What happens to the negative? When you go plus or minus 2i divided by negative 2. I mean, you got both anyways there, right? So it doesn't really matter. So just plus or minus I. Okay, so try that one. So the answer was 3/2. Again, only one answer. So what does that tell you about the? It was a perfect square trinomial, right? I mean, you could see it would have been 2x minus 3 squared. That's what it was. So it was factorable. I mean, if it's factorable, and you can see it, it's probably easier to do it by factoring than doing this whole complicated formula. But if you don't know how, if you're don't see the factoring, by all means do the quadratic formula. So try this one. Now that's plugging it in. Assuming you move the 2x and the 3 to the other side, you should have started out with negative 5x squared plus 5x minus 7. You plug it in the whole quadratic formula, you know, and almost everybody I saw got down pretty close to that. Let me get down to there in a second. So it was over negative 10, but when I split it into two, because a lot of you had this, right? Negative 5 plus or minus square root of negative 115 over negative 10. Of course, the negative comes out of the radical as an I, and then I split it into two terms. Negative 5 over negative 10 is positive 1/2, and since there's a plus or minus anyways in front of this term, you don't have to carry a negative 10, because it's still going to be plus or minus. So you could see we did three kinds of problems. We did a problem where we got two solutions, real. We did one where we got one solution, which is real. And now we got one that's two solutions that's imaginary. And what is it that made them like they were? It all depended on what? It all depends on which part of the quadratic formula. The b squared, yeah, what's underneath the radical is going to determine all the time what kind of answers you get. So that just that little part of the quadratic formula has got a special name, right? It's called the discriminant. Here, you can see it on this slide, using the discriminant. Right, so notice in the top row there, b squared minus 4ac. That's the discriminant. It does not include the square root symbol at all. But again, if b squared minus 4ac is positive, then when you're taking the square root of a positive number, you're going to get two real solutions. If b squared minus 4ac is negative, then when you take the square root, you're going to get two imaginary solutions. If b squared minus 4ac equals 0, then you're doing a plus or minus the square root of 0, which means you're going to get the same number twice. So there's really only one real solution. In terms of the graphs, right, if a parabola crosses the x-axis in two places, that's because the discriminant was positive. If it touches in one place, that was a perfect square trinomial, so it just touches the axis and goes back the other way. If it doesn't cross the axis at all, that means you get imaginary solutions. Okay. So this is like the third bullet on the SOLs that we were supposed to know, is how to find the number and type of solutions based on this thing called the discriminant. So if you're given the question, like this is worded here, find the discriminant of the quadratic equation and give the number and types of solutions. Don't do the whole quadratic formula. That just shows that you probably don't know what it means by discriminant, right? Do only the b squared minus 4ac part. Like here, if I want to do b squared minus 4ac for the first one, that would be negative 8 minus 4 times 1 times 17, which is, oh sorry, negative 8 squared. Okay, let me write it down here. B squared minus 4ac, which is 64 minus 68, negative 4. So based on the value of the discriminant, how many and what type of solutions would I get? Two imaginary, right? I'm taking the square root of a negative number, so that means two imaginary. Okay, the next one, negative 8 squared minus 4 times 1 times 16. That's 64 minus 64, which is 0. Okay, how many and what type of solutions? One real. And then the last one, negative 8 squared minus 4 times 1 times 15. Right, that's 64 minus 60, which is 4. How many and what type of solutions? Two real. So try to do a couple here, and then we'll be done. Try to do the 3, 5, and 6. So the first one, 0. And so what does that tell you? 1 real. Perfect square trinomial. And the negative 271 for the second? 2 imaginary. That's it. And I think that is the end. So again, recognize quadratic formula can be derived by completing the square. Solve quadratic equations using an appropriate strategy. Calculate the discriminant to determine the number of real and complex solutions.